Hello Legacy students, Marsh here. So today we're going to evaluate trig functions of any angle. What you're going to want to have on you. You're going to want to have your calculator, pen or pencil, notes, and then your unit circle chart before you continue. So let's review a little bit about converting radians to degrees and degrees to radians. So what we're going to want to do, let's convert 30 degrees into our radians form, because ultimately we're going to want to know both of them. So I have 30 degrees, and remember it was 30 out of 360, so part over whole equals, I don't know the part for radians, but I do know there is 2 pi radians in one full circle. So let's cross multiply. So I'm going to get 60 pi equals 360x. Let's divide by 360 on both sides. 60 over 360, well that's just pi over 6, right? Because 6 over 36, cancel out the zeros because it's basically dividing by 10. Both can have a 6 come out, so then I'll have 1 pi over 6, or just pi over 6 equals x. So beside 30, I'm going to write a little pi over 6, because you will be able to use this, your unit card, on tests. So go ahead and grab out that little unit circle chart, and you're going to want to write all of the radians right here around the edges. You're going to want to write those on your unit circle chart. So go ahead and pause so you can do that quick. Welcome back. So this is called a unit circle. Now, a unit circle has a center of 0, 0, and its radius is 1 unit. So what that means is from each side here, this is 1 unit. So we can add some coordinates to our picture. So this way, if you think it's 1 unit away, this would be the radius, or the point 1, 0 on our chart, right? Because if this is at 0, 0, I'll move over and I'll get 1, 0. So you're going to want to add some coordinates to your chart. Up at 90 here, this is at 0, 1, because I went not left and right, but I did go up 1, because my radius is 1. This guy, I went left 1, but not up or down, so I went negative 1. This one then, at 270, would be 0, negative 1. The rest of them have different versions of coordinates. So, my unit circle here, guys. We're going to want to think here. So, to understand when to use sine, cosine, and tangent and all that, we're going to think about this reference triangle that goes through x, y. So let's assume right here is the point x, comma, y. And I'm going to drop a perpendicular down. Right here. Kind of like we've been doing to find our reference angle, right? Well, I know that this distance right here is x, and this distance is y. And I also know this radius of this circle is 1. So how can I say what sine, cosine, and tangent is? Well, if this is my theta, sine would have to be opposite over hypotenuse, or y over 1, right? Cosine would have to be adjacent over hypotenuse, which is x over 1. And tangent of theta is going to be y over x, or opposite over adjacent. That is what you're going to want to keep in your mind when we start using the unit circle. But first, we're going to look at taking all of our knowledge that we currently know and putting it all together. So you're going to want special right triangles. You're going to want the unit circle that we're working on. You want this trig function setups. You want to have reference angles. You want a lot of stuff that this chapter already started. Because this is the build-up. This is where we've been trying to get to. Alright, so let's take a look at the cosine of negative 225. So, very first thing, let's draw the angle of negative 225. So I got this right here, around there. So I got 0, negative 90, negative 180, negative 270. So negative 225 would place me about right there, right? So remember, when we found our reference angle, because we ultimately want to find a reference angle, we dropped a perpendicular down to the x-axis. So what would be my reference angle here in the middle of my triangle? So it's 225 to 180, so that would be a difference of 45 degrees, right? Which would mean that this is a 45-degree angle. Which means I have 45, 45, 90 triangle, right? Which we know how to deal with. We know the sides of that triangle right away. So I do know that this triangle has sides of 1, 1, and the square root of 2. But now, notice how I'm going to the left this way. So this is going to be a -1 because it is going to the left. So if you go left or down, you should have negatives. This is going to be a +1, and then I am going to have the square root of 2 for my hypotenuse. So your hypotenuse does not matter if it's negative. It's going to always be a positive hypotenuse. So my cosine is adjacent over hypotenuse, so -1 over the square root of 2, which is basically, because I got to multiply the square root of 2 on top and bottom, so I rationalize the denominator. So I'm going to get negative square root of 2 all over 2 for my final answer. Let's try another one. Secant of 300. So ultimately, let's find the cosine, right? So let's draw our angle of 300. So I got 0, 90, 270, 3, whoa, skipped 180. My bad, guys. 270. So 300 is about right there. Draw my angle down. So I have an angle that goes from 300 to 360. So I believe that's going to be a 60-degree reference angle, right? So this is a 30. And now I have a 30, 60, 90 triangle. We also know how to deal with that. So we're going to have across from 30, 1. Square root of 3 there, because across from the long leg was the square root of 3, and then our hypotenuse was 2. Now, since my long leg is going downwards, this is going to be the negative square root of 3. So you're going to want to be careful about that. Once you put in your side lengths, make sure you didn't go down or left, okay? So now I want secant, but let's find just cosine first. So cosine, remember, is adjacent over hypotenuse, which would be 1 over 2. So I do know the cosine of 300. It would be 1 over 2. Secant is cosine flipped, right? So this would just be 2 over 1, which is just 2. What about the cotangent of -8 pi over 3? Well, very first thing, I don't know what 8 pi over 3 is. So let's double check our unit circle chart where we wrote in all of our degrees or all of our radians. 8 pi over 3 is not on our chart. So looks like we're going to have to do some conversion. So I don't know the degrees over 360, but I do know how many radians I have out of 2 pi. So cross multiply here. So I'm going to get 2 pi x equals 360 times -8 pi over 3 is -960 pi. Right? Because 360 times 8 divided by 3, 960. Let's divide by 2 pi on both sides. So I get x equals -480 degrees. So 480 degrees. That's more than 360. So I'm going to add 360 on so I can see what the actual angle is that's coterminal to -480. That way I don't have to think over too much. So that's -120, right? So ultimately, -480 would end up the same place as -120. Because remember that clock thing that we did. So if I put my angle here, 0, -90, -180, -270. So -120 would put me about right here. Drop my perpendicular down. So this would be a 60-degree angle, right? Because 120 to 180 is 60 degrees. So this is 30. So it looks like I got 1, square root of 3, and 2 around my edges. So double check, did I go left or down? Looks like I did. So this should be a -1, and this should be a negative square root of 3, because I went left, so it is in a negative direction. And I want cotangent, but let's first think about tangent, because tangent's going to help us better. So tangent of this angle would be opposite over adjacent, so negative square root of 3 over negative 1, which is just square root of 3, right? So my cotangent needs to be 1 over the square root of 3. Rationalize the denominator quick. So we'll get square root of 3 over 3 for our final answer. Let's try one more here. So I got the sine of 3 pi over 2. So check my unit circle here. That's 270, right? So 0, 90, 180, 270. So my angle will be right here. I cannot drop a perpendicular. I can't make a triangle. What are we going to do? So here's when that unit circle and those coordinates are going to come into play. So it's best to use our knowledge of the unit circle when we have what's known as a quadrantal angle. So basically an angle whose terminal side makes it impossible to draw a reference triangle, which is exactly what we're having issues with right now. So let's find the sine of 3 pi over 2. Think about it. Reference triangle. 270 had a 0, negative 1 for a coordinate, right? Because remember, my radius of my circle is 1. Since I'm going down 1, my point would be at 0, negative 1. And they want the sine. Remember, sine, we found out when we did our our little drawing of triangle, was my y variable over my radius. So my y is negative 1, and my radius is always going to be 1. So this is basically negative 1. The sine of 3 pi over 2, aka the sine of 270, is negative 1. I know these are pretty difficult. We're going to spend a couple of days on here just so you get comfortable. We'll work on them together. But that is the end of the video. See you later, Sabers.